It's really nice to be back in London and to see so many familiar faces and also lots of new people, which is great. And I'm just overwhelmed by the turnout, so thank you. So, as Alex says, this talk is records and sealed types. My name is Ben Evans. I use he, him pronouns. And because I work for a public company, I have to show you this slide. And what it means is, despite the fact that I don't work for Oracle and don't even have a commit pit on OpenJDK, you shouldn't take anything I'm about to say about the future of Java at all seriously, especially if you're going to make financial decisions based upon it, which I'm sure many of you were. So, for those of you who have not met me before, I'm Principal Engineer and Architect for JVM Technologies at New Relic, based in sunny Barcelona, which is lovely. Before that, I co-founded a company called JClarity with the aforementioned Martin Verburg, which was based out of the London Java community originally, and last year we sold it to Microsoft. So that was quite an eventful few months. Yeah, if you want to hear about that, come and buy me a beer later on. Before JClarity, I was Chief Architect for Listed Derivatives at Deutsche Bank, and before that at Morgan Stanley, where I did a number of things, including the Google IPO. Again, those are bar stories, if you want to hear them later. I'm also kind of known for some of my work in the community. I'm a Java champion, if you know what that is. I'm Java 1 Rockstar Speaker, which I probably should rename, given that Java 1 hasn't existed for a number of years now, and younger people in the audience might not even know what it is. So I should probably change that part of my intro slide. I also served on the Java Community Process Executive Committee, which is the body that makes all new Java standards, for 6 years. And then during my time living in London, I was part of the organising team for the London Java community and co-founded a project that you might have heard of called Adopt OpenJDK. Okay, so with that's probably talking enough about me for the rest of the talk. So instead, I want to talk about something which I know is very dear to everyone's hearts. I'm talking, of course, about enums. 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 Okay, so now everyone's looking at me and they're thinking, why on earth has Ben just said the word enums 6 times in a row? We're talking about records and sealed types, aren't we? Well, we are. So why enums? Well, there's a general principle and there's a specific principle. And I'm going to talk about the general principle first. The general principle is part of language evolution, is that patterns in one language become language features in languages that follow. Okay, think about that. A pattern, as we all know, especially in an object-oriented language, is the idea that you have a small group of classes that somehow operate to provide a reusable and recognizable language construct. So my thesis is that over time, languages, which obviously belong to a community of languages that existed beforehand, are able to take things which were encoded as patterns and turn them into part of the language core. So what do I mean? You know, that seems like a pretty bold statement that I might have to justify. So I mean things like vtables in C, becoming the virtual keyword in C++. Hands up if we've got C++ programmers in the room, anyone that knows some C++. So a few people here know what I'm talking about. The idea of a table of function pointers turning into the virtual keyword. And of course in Java, we've taken this one step further. We don't have a virtual keyword anymore. Virtual has become so much part of the language landscape that it actually disappears from view, which is the stage of evolution which is beyond the one that I'm talking about here. From a pattern to a language feature to being just so much part of the woodwork and so much part of the background that you cease to even see it as a feature, never mind a pattern anymore. The iterator pattern in C++ becomes the iterator interface in Java. And if you've ever read the old Gang of 4 patterns book, you'll find patterns like iterator in there. And for younger people, you look at it with fresh eyes and you think, why are we talking about this? Why is this a pattern? It's just a thing. It's just a part of the library. It's just become part of the landscape. And of course, you knew I'd get back to enums. So the enum approach in C++, which of course is just a horrible hack over integers. Well, in Java, there's quite a bit more to it than that. So that's the general principle. I could list out a bunch of others, but I thought that those were the closest to the surface to try to at least provide some sort of anecdotal justification for the point that I'm trying to impress upon you here. But then, of course, there's actually the specifics about Java's enums individually. Java enums are a restricted form of class. They have semantics that are defined by a pattern. That pattern we might call finitely many instances. And notice the way that I've framed this. The semantics are defined by a pattern. From the pattern comes compact syntax. And it's that way around. The semantics are defined by the pattern. The syntax comes from the semantics. Okay? So now, let's actually go to my first demo of the day. Given the fact I found a boiled sweet that had been through the washing machine in my jeans just before going on and had a near miss with a pigeon and bad things come in threes, I think the chances that all of my demos are going to go successfully today are basically zero. So just please bear with me when they inevitably go wrong. So how is my font size? Bigger? Hands up for okay, cool. How's that? Is that better? Okay, back row says yes. So what have we got here? Okay, well let's take, I don't know, let's take the colors maybe. So I have a simple color, enum. Yeah, pretty much the simplest thing you could think of when doing an enum. And because I have to work with multiple JDKs, let's just use some Java 14. Why not? Okay, so now let's just javac. So far, so good. And so just the Java P tool to disassemble it. No one's scared of a bit of bytecode, are they? Good. So what have we got? Well, we can see that each of the individual names have been turned into public static final fields, each of the correct type. We have a thing called values, which gets back this field $values, which has an array of color in it. That's actually a private field, so it doesn't show up in this particular view. But then we clone that to return this as a value field. There's an ancient region in there for why you do it that way, to do with serialization, but I shan't trouble you with that. You also have a color value of which you use to look up this. And notice that there's a class called javalang enum up here, which every enum extends. Now, if you go and try and extend this class directly, the compiler won't let you. What else have we got to say in here? Okay, and then we've got this static initializer block down here, which sets up and basically initializes each of the enum constants, which now exist as public static fields. Okay? That's a lot of generated code, a lot of stuff which has been provided by, well, that many characters. So decompiling it actually shows us that we already have language constructs in Java where stuff is being auto-generated for us by the compiler. So when I come on to show you some things with records in particular, this is not a new idea that we have the compiler doing significant work for us. Okay, I'm just going to pause there. That probably is enough about enums for right now, although, spoiler, I'll be coming back to talk about them in a bit. Okay, so now I want to introduce something you might not have been aware of in OpenJDK, which is this thing, which is Project Amber. Hands up if you know about Project Amber. Okay, wow, I would have expected lots more people to know about it. I was expecting about 50-50, in fact, and I didn't get close to that. So in which case, it might be a good idea to also ask this at this point. Hands up if you are running Java 11 in production. Okay, better than expected. Just out of interest, because I'm curious about these things, is anyone running a non-LTS version of Java? So 13 or 12 or 10 or 9? Okay. You're some of the first people I've ever seen run non-LTS in production. Everybody's running either 8 or 11, apart from you guys, apparently. That's cool. I'll have a chat to you later. I'm curious. So Project Amber is one of the projects which has been happening in OpenJDK to try to explore research directions. And there are several of these things out there. The one which you might have heard of more than Amber is Project Valhalla. Who's heard of Project Valhalla? Hands up. Yeah, it's everybody. Everyone wants to hear about inline types and inline classes. And that's kind of the big, bombastic, boil the ocean, change the entire world project. Now, the goals of Project Amber are rather more modest, or so it at first appears. So Project Amber is about trying to find smaller, in some sense, features which are about productivity and which are core to the Java language itself. There's very little VM level change necessary for these things. There's a bit of stuff in the compiler. There's a bit of stuff in the class file format, but very little in the type system and almost nothing in the VM. So that means that you can try to deliver your large goal by breaking it apart into smaller pieces. And if you build one feature on top of the other in the right way, you might get to some quite surprising places. You know, the old saying about you might grow a mighty oak from a tiny acorn, or in this case, a sequence of delivered tiny acorns which are part of a concerted set of deliveries to build up some much larger ideas. Okay, so that's Project Amber. What else? Well, let's talk about records. What are they? Okay, and this is by analogy with enums, and you'll hopefully start to see now why I spent the first 10 to 15 minutes talking about enums. We want a first-class support for modeling a data-only aggregate. There's a pattern here. The pattern is defining some semantics for us. The pattern is called the state, the whole state, and nothing but the state, which sounds, remarkably totalitarian. So maybe we should find a better name for it. We could call it the data carrier pattern. What it means is that there is a subsetting of classes, a reduced form of a class, where we want to make it clear that nothing really happens except that the instances of the class are totally and completely defined by the state that they carry. And they have no real further semantics or further behavior other than that. Okay? Turns out that this also closes a rather annoying gap in Java's type system, which we've had since the very beginning. And then notice that our next goal is to provide a language level syntax for this pattern that we came from up here. And finally, and notice that it's at the bottom of this list, and this is kind of in descending order of importance, it reduces the class boilerplate. Okay, and this is actually a Java example of a very important principle in programming language design. Wadler's law. Hands up if you've heard of Philip Wadler, one of the originators of Haskell. Yeah, and Wadler's law has this idea. The emotional intensity of debate on a language feature increases. So the debate gets more intense and more vicious and more unpleasant the further down this list you go. Semantics, then syntax, then lexical syntax, then comments. Now, given that we're Java people, I might also put in a new entry here between lexical syntax and comments, multi-line strings. A feature which is effectively trivial, but yet which has attracted more debate than anything that I can think of recently. Because I was around for the Java 7 days, I would also put strings and switch here as well. And Wadler's point here is that the reason why this happens, the reason why people debate these things more and more as you go down the scale, is because there are more and more people who feel competent enough to have an opinion about them. At the very highest levels of the language, there are very few people who can coherently argue about what major language semantics should look like. Everybody has an opinion about what comments should look like. So the other term for this is called byte shedding. So if you've ever heard the idea of byte shedding, which really came from the operating system community, whereas in the programming language community, we like to call it Wadler's law instead. But, because we want to talk about boilerplate, let's talk about boilerplate. It's nice and accessible. All the stuff you hate to type, all the things you don't want to, the toStrings, the hash code, the equals, the getters, public constructors, the list goes on. And what do? Well, there's really two things you can do. You can either get the IDE to generate them, hands up if you do that, and keep your hand up if you have had a bug in production which caused an outage by not keeping these things up to date by regenerating them when you know you should have. Yeah, I thought so. There always are. Okay? So then, you might think, well, let's solve this problem in another way. Let's have Lombok. Yeah, the laughs in the back of the room tell me that there are also people in here who've been bitten by Lombok. And Lombok is really not a good solution for this because it does some really terrible things in the way that it's implemented. It's extremely clever, but the older you get and the more senior you hopefully you get as a programmer, the less in love you are with clever solutions. Okay? So we need something new. If we're going to get rid of the boilerplate, how are we going to do it? Well, let's start with the Java cache flow class like this. We set it up and notice how we've got this arranged. We've got a public constructor. And notice that we've got an awful lot of repetition here. We have a currency and a field called currency. So parameter, field, method, all of which are doing the same thing. They are referring to the same fundamental thing. Yeah? So what we have is a pattern. We are doing a lot of typing here to represent the pattern that this thing is just these things, and they're accessed like this. And there is no other way of doing it, and there is no more semantics other than those fields. Fortunately, I found some help. By the way, if you're looking at the PDF while we're doing this, this is not going to look great on the PDF. But what we get is this. It's legal Java 14 syntax in preview mode, and we have got rid of all of the boilerplate. Yeah? But that's not the important thing. Remember Waddler's law. The important thing is what we're saying is that those three things are everything which matters about one of those. That is nothing more than the sum of these parts, or maybe I should say the product of these parts. So what are they? If we're concerned with semantics, what are our semantics here? So, this is kind of backwards. I'm showing you the answer before I've really shown you the question. But when Brian and the others on the expert group were designing it, this was the question they started with. In the design space, what are these things? What could a record be? And they come up with really 4 possible alternatives. They could be boilerplate reduction. Yeah, they could be. And for some people, that might have been the right answer. But it does kind of violate the Waddler's law principle. They could be Java beans. Hands up if you were really hoping these were going to be Java beans. Only a few people, or at least only a few people that are prepared to admit it in front of a packed room. Obviously, as you can probably guess the way that I've set this up, they're not Java beans. They don't have setters, and the naming convention for the getter methods as on the previous slides, you may well have noticed, was not a Java bean convention. Okay? They could be these things called product types as a form of algebraic data type. Or they could be something in the middle, a named tuple, which is kind of similar to a product type, but it's got a name. So if you've been around Java for a while, you will know that actually we tend to like names in Java. We're very sure that everything in our language, every type, has a name. Even if we can kind of elide it or get rid of it or not have to talk about it explicitly, as we do with Lambda expressions, deep buried in the heart of it, there actually is a name involved. So you probably won't be surprised if I tell you that actually records are named tuples. They have names. They are not structural typing. They emphasize the semantics above everything else. They emphasize the fact that it is simply a collection of fields and nothing more elaborate than that. And that there is a tight binding between what you call the parameters versus what you call the fields versus what you call the accessor methods. And that's just the way that we do it. And this is not to be a complete replacement for everything that classes do. If this pattern doesn't fit with what you're doing, don't use it. It's there for those cases which people believe are very common, where this is what you do want. And one of the things that I found about it as I've been working with them is that it's actually very natural. You kind of get a sense quite early on when working and building with records, this thing has other semantics. It's not just a plain collection of fields. It therefore needs to be a fully fledged class. And that's okay. That's okay. So let's try the second demo. And for this one, Oh, look, I think I'm going to... Oh, I think I should probably actually mirror display. I think that might help. So I started my career in finance, as you saw from my opening slide. At Deutsche Bank, before I was involved in listed derivatives, I was actually in foreign exchange. So I secretly have a bit of a soft spot for FX applications. Do we have any financial developers in the room? Anyone in FX? A few people in FX. OK. So this is not to be taken seriously as an FX application. I would not put this into production. I'm not claiming that I would. It's a soon-to-be open source application, which basically is just designed to show off Java 14 features, just as a reference application. If once it's open source, if you want to send me pull requests and bug reports about how terrible my matching engine code is, I'll be very happy to accept them. So the way it's laid out, it's called Foxy. And under the Foxy packages, we have a couple of things. We have the domain model, we have an engine, and then we just have a very simple Jetty handler, which is just there for status checking and making sure that Kubernetes doesn't kill it and stuff like that. So I'm going to focus first of all on the domain. So I've got a bunch of enums, currency pairs, which are going to be what I'm going to trade. Oh, yes, of course. How's that? Is that a better size? More? Good. So I've got some currency pairs as enums. I have what should I show an example of? Oh, I'll show you this one. This is the... Come on. So this is actually a fully fledged record. If you'll notice very carefully at the top left of the screen up here, this is the early access preview of IntelliJ. So this is actually able to cope with preview features in 14 and so forth. So I define my record to be an FX order, to have a number of units, currency pair we're trading, the side, a price, a center, a time to live. And because I want to do everything immutably, because records are immutable, I want to chain the order to say this one came from another order originally. So that if I trade and something partially matches one order, I can link it back to an original order that was originally sent in. Okay? So that's the structure of my data. And you'll notice something quite interesting here, which is, well, down here I've got some static factory methods. And I found that this is a pattern for working with records that works really well, is rather than having multiple constructors, this is very much an emerging pattern. I'm quite happy to be shot down about this once we've actually got a bit of experience working with records. But I find that the static factory and a single canonical constructor is actually a better way to work with these. So in these, all that happens is these just basically fill in some parameters, because of course we don't have default parameters in Java, and then they create new objects. So the thing I want to draw your attention to is this thing down here. Look, it just fits on one slide. In a class declaration, you say public class, name of class, curly braces, then you say constructor, and the parameters live on the constructor declaration. With records, our parameter declarations live on the record declaration itself. So in a duality of syntax, the constructor does not need to repeat that list of parameters. And this is why I think the canonical constructor approach works well. Because I know what the parameters are. Because they're the parameters of the record itself. So if I want to do anything special in the constructor, I don't have to repeat myself. I can actually just say, this thing is the constructor, and oh look, I do all these things in it. And it's very straightforward. It's simply some states checking. I want to make sure that any time I create one of these order objects, it's completely set up the way I want. And any misbehaving things, like trying to pass in nulls to the enum types, we'll just throw in an argument exception. Okay, so this is actually called a compact constructor because it doesn't have full declaration, and because I don't actually say to set all the parameters. I don't need to. It's taken as read that in these constructors at the very end, if you've passed all the checking, you can set all of these fields. So that will be automatically generated in the compiler as well. So The units, the currency pair, the side, all of the other parameters will be set invisibly down here. Okay? Which, by the way, shows us one way in which these are better than structural or shape-based tuples. I can do this kind of error checking because I actually have a constructor to hang them off. If all I was doing was taking things and putting them together into a round bracketed tuple of multi-values, there would be nowhere for this to actually run. So one of the key advantages of having the named approach is to do it this way. I might take questions at the end. So that's the FX order object. We've got a couple of others as well. I've got an FX response. Oh yeah, I'll show you this one. Yeah, and I've got this sad little code comment up here, which says this interface really wants to be a sealed interface, but there are no sealed types yet. So instead, what I've had to do is have an interface called FX response, and then we can have this. So yes, you can have records that implement interfaces. But this is the design sense that it's actually difficult to build out of, because how much further down this route you want to go before this thing is genuinely a class is a separate question. In this case, I'm using FX response purely as extra type information. And if you notice, it was actually a marker interface. Yeah, and it is genuinely. I think that this pattern would be more common if we did have sealed types in play as well. Okay, so far so good. I'm just going to show you one other thing which happens, which is actually not in the domain package, but eventually we have to get back to this class here. And this class is what I've called a client-side manager. This basically is managing all the connections for an incoming protocol in the financial industry called FIX. And what we're going to do is we are going to connect to the main matching engine by a pair of blocking queues. We break open the message, we send it down as an FX order, we get a response back. So basically, the communication to the matching engine is done with queues for a bunch of different reasons, not least of which it helps with testing. But the thing I want to draw your attention to is this line here, because I've snuck in another new feature. This is also in Java 14 in preview mode. You see the syntax? If response instance of fx reject, f reject. So this is combining two things at once. It's combining an instance of test and a variable declaration. You know, I could change the code here. I could write something like this. Yeah? And that is what we would expect. You know, and as Java programmers, I think we've been steered away over the years from doing much with instance of. It's considered un-OO and un-Java-y. But now, take that back out again. We can do this. So it's clean, there's no unsightly cast. And, okay, this looks like a small language feature. It's a very small language feature. But sometimes small language features are where this stuff starts from. Yeah? This is called an instance of pattern. And for those of you who speak some other languages, maybe Scala, maybe Haskell, maybe some others, the word pattern has a different connotation here to how it's typically used in Java. I don't mean a software engineering pattern, and I don't mean a regular expression. I mean the other type of pattern. And this is the first example we see of it. Okay, so just another little teaser there. Let's come back. How are we doing? 20 minutes. A couple of other things I want to tell you about records, and then we should move on and talk about sealed types. So the first of them is that records have an additional equals invariant. So this is in addition to your standard equals hashcode contract, but for records, you must also obey the following. if you take the individual components of the record and do a copy constructor based on it, basically just say a new record made up of the same components as the old one, then the copy must be equal to the original in a dot equals sense. If you think about it, that follows directly from the semantics. The state, the whole state, and nothing but the state. So if that's what if we mean that, this must be true. Okay? There's a second point, again, which seems incredibly minor and trivial, but it's going to turn out to have a deep connection to the Instanceof pattern we just meant. Serialization. There is a constraint on how records must be serialized. Serialization, as Brian tells us, is a second mechanism for constructor. It's invisible but public constructor and an invisible but public set of accesses for your internal state. The next line is but not for records. Records must be serialized and deserialized using the idea that they are simply the composition of their state components. You must obey that rule. And if you do anything else, bad things are going to happen to you. Okay? So one other minor point that I want to make before we start to look at sealed types, and again, this will become obvious as to why. Let's talk about enums. Specifically, let's talk about Java switch expressions. Hands up if you've seen the Java switch expression before. Yeah, lots of people have. It's quite nice. Personally, I would have much preferred it if we'd actually been able to call it something other than switch. But, you know, oh well, lost that one as well. So the idea is that now switch comes not only as a C-like statement form, but also as something that must return an expression. Okay? And you can do some nice things in it. You can have multiple labels which correspond to the same thing. Notice that in here what we're using is an enum called day of week out of Java time. And if it returns Saturday or Sunday, it's false. And if it returns Monday to Friday, it's true. And then I'm going to hand wave away doing bank holidays and anything like that out of this question. Okay. Now, there's something quite interesting about this. Can you see what's not present here that you might expect in other kinds of switches? Default. Yeah, the default case is missing. Why is the default case missing? Because I've covered the entire space. The enums are implementing a pattern. The pattern is called finitely many instances. This means that the compiler can check this code and know that it is impossible for us not to go down either branch. Quick teaser question. What happens if I for some reason I pass null into this? No? Null pointer exception, absolutely. Yeah, so this either throws an exception. If it doesn't throw an exception, all cases are covered. And the compiler can check that and verify that at compile time. Okay, so now let's talk about sealed types. So let's remember one more time. Enums. Enums are instances of classes. Enums are exhaustive. Two questions arise. First of all, if I have a pet as an enum, and I have two instances, cat and dog, well, what happens if I want multiple cats or multiple dogs? How can I have a way of saying that a pet object either is a cat object or is a dog object? Yeah, that's a new type of OO construct. It's not straightforward has a or is a. It is a or B. That's what the concept is. You may have seen this concept in other languages, in C# and Scala, etc. It's actually quite an old idea. Very little about what I'm talking about actually is theoretically new, even if it's just mostly been surfaced in modern JVM languages like Java, like Scala and Kotlin. Okay, so returning to this, how do we do this? How do we represent this? How do we model this in existing Java syntax? Well, two options. Option one, the state field. So you have a single class called pet, which has a field of enum type that holds the real type. So effectively, we're breaking the OO-ness of this. We're making the programmer keep track of the type bits by examining the field to say, is this a cat or is this a dog? Right? So we're moving something which is in the proper domain of the type system down into the programmer's bookkeeping code. And that's horrible. The second problem that you have is that you can't have any type-specific functionality. The cat can't purr. Well, because your choice would be either cat doesn't purr or dog does purr. You either superset all of the functionality into the base class, or you disallow it altogether. And if that starts to sound like a nasty ORM mismatch problem, that's because it essentially is the same thing. This is an ORM anti-pattern rewritten into pure Java code. Okay, option 2, the abstract base. We could start with an abstract base, a pet class, with a package private constructor and 2 separate concrete subclasses within the same package, and only they can call the package private constructor, so everything is fine. Apart from this abstraction leaks. Outside of the JDK packages, there's no protection. Maybe modules help, but what do you do about if you need this construction in one of your API packages of the module? It can still be defeated there. What about reflection? That doesn't help either. So let's see how we actually do solve this. We actually introduce official supported sealed types. Okay? A sealed type is one that can be extended by a known list of types, but no others. And that's enforced not at compiler level, but also at class file format and runtime level as well. Okay? There are different ways of thinking about them. In Java's case, the way that we think about them, we believe that we should treat them properly as almost final classes. That they are a class which admits a known list of subtypes, but they're really kind of part of the finality mechanism rather than anything else. Because in Java as it stands, we have 2 options, open and closed. You're final or you're open for extension by basically anyone. This is a halfway house. This is a middle ground between the 2. We've got 2 new keywords, sealed and permits. I teased those in a comment in the records code earlier, but that's what they are. And notice that, just to build some bridges with other languages, these are also sometimes known as union types in other languages. Particularly people talk about disjoint unions. And curiously, it's actually tied into a Java language feature that already exists. Sometimes big things go from small places. Does anyone know the one place in the Java language where we already have something that looks like a bit like this, or something that looks like a union type? No, not var. Actually, that would technically be an intersection type. I think I know where you're going with that, and it's related, but it's not quite right. Yes. Objects being null. No, the null type is special, so that's not really an answer either. That's a very interesting question, but that relates to things like how Kotlin handles nullability. I'm short of time, so I'm going to call it here. Multi-catch. The multi-catch of an expression is one of those, or one of those, or one of those. Yeah. And for those of you that speak other languages, notably Haskell, you can probably see why I'm shying away from calling these union types. It's to do with the fact that the Java type system is single-rooted, at least for references. Okay, something else we need to make all of this work. Hands up if you've heard of these things. That pitch doesn't go out quite as well as I'd hoped. Java 11 nestmates. Hands up if you've heard of nestmates. Nobody, wow. Inner classes done correctly. Fixing a design bug that goes all the way back to Java 1.1. Actually making inner classes work the way that they were always intended to. And with that, it's demo time. Okay. Unfortunately, sealed types aren't actually in Java 14 yet. So here's one I made earlier. My own personal build of OpenJDK in order to allow us to play with sealed types. what do we want to do? Super. So here's what they look like. Public abstract sealed class permits cat and dog. This is a standard pattern to have the bases be abstract so that you don't actually have to deal with the supernode case. You are simply dealing with the possible disjoint subcases. So we have a name, we have an abstract speaking method, and then we just have a very simple constructor. So now we have a public final class. Yes, you do need to say final for all of these. I would much prefer it if this was final by default. But there are some particularly bizarre use cases where you want not all of the classes which extend this to be final. Why you would ever want that backdoor to break the sealedness, I don't know. But there we go. So we have a constructor, and now we have a couple of things. We've got the implementation of speak, which is part of the base functionality. But now, crucially, I've got my own functionality. I can go and hunt mice, which is handy if you're a cat. So this is how it's laid out. Let's just show some compilation. Oh, and I suddenly realised I didn't actually show you the bytecode decompilation of a record either, so let's just show that too. Oh, I need to change Javas for that. Never mind. It's quite an interesting thing to notice here is that the cat class really shows no real sign of having been the subtype of a sealed class at all. And it really doesn't need to. The actual sealing magic happens in the supertype. Now you might notice there's something a bit weird down here with some invoke dynamic, but don't be confused by that. That's simply the way that in modern Java, things that are to do with shaping, such as string concatenation and various other methods, are now being built by invoke dynamic factories. So that basically is in just the same way as we did for lambdas. You're going to see that more and more. Dynamic stuff will be done using invoke dynamic magic. So let's actually look at the sealed type case. Okay, again, nothing really to see here. We actually need to dig in. You see right down at the bottom, there's a new thing which says permitted subtypes. So that means that this class, when you try to compile anything new, whether you have the original Java file for this or whether you have a class file compiled version of this, if you are not in this list, you will not get compiled. So you will be rejected by the compiler. So this solves the problems that we saw in the other half, where with a package private constructor, you could still someone could still get around it. This also will prevent reflection as well. So this really is a completely watertight mechanism. Is there anything else I wanted to show in there? Okay, so let's just very quickly, I'll switch to Java 14 again. Just because it's fun to look at these. Class. There we go. So, oh look, there's a new class called JavaLang Record. And just as for enums, if you try to directly extend that, the compiler won't let you. We have the public constructor, which has been automatically created and just basically does all of the things that you would expect a simple constructor to do. You have toString, hashcode, and equals, which are all provided for you by these invoke dynamic factories that I was just talking about. And then you have some getter methods, and that's it. So all of that boilerplate creation has been done in exactly the same way as it would be for enums. Okay. So. Okay, so here's the path so far. These are some of the pieces we've needed to put together. Nestmates, inner classes done right. Switch expressions, which are now actually a standardized version in Java 14. Records, instance of patterns. At some point, maybe 16, we'll get sealed types as well. There are also some other pieces which are coming into play behind the scenes. The instance of pattern, a deconstruction pattern, because we can now do things like think about how the instance of pattern was written, where you tested something and then you declared a variable. Well, imagine doing that to a record. What do we know about records? Records are just the product of their parts. So what about declaring not a new variable of record type, but destructuring it in just the same way as we do in many other languages back into its components? So those start to build towards a feature called pattern matching. Not patterns as regular expressions, not patterns as language ideas, but the idea of being able to compose and decompose the structures of our objects on the fly. Yeah, so hands up, have we got any Scala users? Yeah, so think match expressions with similar power, but implemented down in the runtime, down at VM level. So records are about semantics. They implement a pattern. They're not a general replacement. They're very useful, though. Sealed types are a new OO construct, and together they make up this idea called algebraic data types. For people that come from pure functional languages like Haskell, there are restrictions. The Java type system can't be fully modified to do exactly the same way that it works elsewhere, but this is our version of how algebraic data types will work. The big hope, and again, I work for a public company, nothing I can say should be taken as gospel when it's forward-looking. Hopefully, I would think that all of this would be final by Java 17. One thing I should also make clear is records have nothing to do with inline types. Inline classes and records are completely orthogonal and completely independent concepts. Records, sealed types, pattern matching by 17, yes, I think that's reasonable. I don't know about inline classes. Okay, so if you might want to grab a couple of URLs here. Brian was kind enough to do an article for us about records in InfoQ. So I'll just let people take a picture here. And a couple of my pieces about, for Oracle's Java Magazine, records and sealed types on the JVM. So what can you do to help? Try out the new Java 14 and I suppose 15 betas now, because 14 will be released in a couple of weeks' time. Keep an eye out for the sealed type betas and deconstruction patterns. Please try and write some code using the new features. Even if it's just research or innovation time, as we call it at New Relic, and give feedback, the sooner is better. I actually found that records were a fantastic feature to start using in the code, and I hope to actually release that demo application I showed you as open source pretty soon. To conclude, I have a few tickets for my book, which I'm going to be giving away and signing at the New Relic booth at 12:40 today. Let me see how many tickets I've got, and I'll take questions.
Thanks a lot, Ben. Any questions?
Two questions. One, do records allow validation annotations on the parameters so that Java Beans validation, for example, can be triggered? And second, so records are not Java Beans, but it is Java Beans now that is a lot of useless boilerplate, and this is why we use Lombok. So will it really be so beneficial to the current applications and the current libraries that we use for all the Java Beans stuff?
Okay, so two good questions. The first of which is, yes, you can use validation annotations on them. There's some work to do to bridge these because you want to think carefully about what that means and make sure you don't bring in additional semantics. Secondly, it's unfortunate that they can't be easily retrofitted to Java Beans capabilities, but the problem is you have other guarantees like the copy constructor and the serialization, which you can't definitively rule in or out. People do some messed up things with Java beans, and people also use the Java beans conventions when they also have additional semantics beyond what is meant in the Java beans. So unfortunately, I think this is an example of a language feature where people are being cautious and just doing what you can with the first cut. Will someone come up with a clever bridging thing? I'm sure they will. And for all that Lombok has surface level advantages, the more I've used it, the more I've come to realize that actually it's a bad solution. And that's not to say anything bad about the technical ability of the people that wrote it. They did the best they could with the design space they had, but it doesn't make it a good solution. The boilerplate, although it's bad, in my opinion, is the lesser of two evils compared to what Lombok does to you. Great question, Slo.
Thank you.
Next question.
Hi, thank you for the talk. I also have two questions. First, with regards to sealed type, does the permitted type have to be, do the permitted types have to be in the same package as in your example, or is it just for brevity?
I'm pretty sure it was just from brevity. It's a while since I wrote that code, but I think they as long as it's a correct, fully qualified name, I think you're fine.
Right. And the second question, can records be generic?
Can records be generic? Oh, great question. Answer, no, they can't. There are good reasons for that. I'll tell you about it later if you want to know. Yeah, who's next? Scott.
You gave a bit of a hint there about permitted types not being final by default because there was good reasons for it. Could you give an insight of what those good reasons might be? That seems like quite a strong anti-pattern.
Not being final by default. Yeah. I would have to point you to the appropriate place on the mailing list where Brian comes up with an example where in the example it definitely would be problematic if they were final by default. This was part of the discussion about whether we should also have a no-op keyword called non-final. Because the other proposal was to make them final by default, introduce a new hyphenated keyword saying non-final, and then basically allow that the other way around so that they were final by default, but you could specify them non-final. I'd need to find the appropriate reference.
One last question.
One last question.
I follow the pattern of two questions. How do the records differ from Scala case classes, and can you implement interfaces?
Yes, I showed an example of implementing interfaces.
Sorry.
And no, the Scala class classes are a good, a good mental model, I think. They're similar in some ways. What will happen, in my opinion, given the way that we've seen this happen with other features in the Java language, is I wouldn't be at all surprised that in a future version, Scala 3.3 or 3.5, that Scala case classes are retrofitted on top of records. That's what happened with traits. Stateless traits just became interfaces with default methods. I think the same thing will happen here.
Okay, so we're out of time now. Let's make a move, see if we can get a coffee before everyone else does. One last time, thank you, Ben Evans.